This whole idea of limits and whether they exist or not brings up the idea, or brings us to the idea of continuity in a function. Now recall in 2 space, a function is said to be continuous at a if the limit as x approaches a of f of x is equal to f of a. And so in other words, the limit exists, and not only does it exist, because this implies that you took the limit from the left and from the right, not only does it exist, but it is very specifically equal to f of a. Now the same exact idea holds true for 3 space. Now we say that f of xy is continuous at ab if the limit as xy approaches ab of f of xy, so it equals f of a of b. So this is saying that the limit exists, and very specifically it's at this point, is equal to this point. Now we can see that function is continuous on D, because this is just making reference to being continuous at a single point. So we can say that it's continuous on D. Remember, D is this disk, this region about AB. If f is continuous for all AB in D. In other words, given D is some disk about AB, there are no holes or vertical asymptotes. No unusual or sharp behavior. That's what it would mean to be continuous in this region D about AB. So let's consider a polynomial function of 2 variables, which is the sum of terms of the form c x to the m, y to the m, for c being, of course, a real number, and m and n being positive integers. Are polynomial functions of this form continuous, such as an example, f of xy equals, say, x cubed plus 3xy squared plus x squared minus 2x plus 1. Is this going to be continuous? And the answer is, well, yeah, it is. It's continuous for all xy, just as it is in 2 space. You remember in 2 space, if I have f of x and g of x, and f is continuous everywhere, it's a polynomial. G of x is continuous everywhere because it's a polynomial. If I multiply those together, I still have something continuous. And really, that's all that's going on here. I can multiply the 2 things together, and because it's a polynomial, this will be continuous everywhere. If I expand this idea to that of rational functions, then I can say, well, first of all, a rational function in 2 variables is a ratio of 2 polynomials in 2 variables. So it would then have the form, say, g of xy, if this is a rational function, equals p of xy divided by q of xy, where both p and q are, in fact, polynomial functions in 2 variables. So I want to see here, yeah, both p and q are polynomials in 2 variables, of course. And of course, the only obvious restriction is that q of xy has to be non-zero. All polynomials in 2 variables are continuous on R2. And we see R2 here because I have x and y. So it's continuous over its domain. And likewise, all rational function 2 variables are continuous over their domain. And i.e., we can skip that because I just wrote it, what it means right there.